Okay, picture this. You've invested in a stunning 4K display. You've got incredible source material. Maybe it's a high-end gaming console or a professional media server.
Right.
But then you hit the wall. You've got this huge room or maybe an older building with like impossible cabling.
It happens all the time.
Exactly. And running a standard short HDMI cable, it's not going to happen.
Yeah.
So how do you possibly get that pristine, uncompromised 4K signal from point A to point B without, a mess of wires, signal dropouts, or breaking the bank?
That's the core challenge. Absolutely.
So today we're doing a deep dive into what looks like a really elegant solution. We're looking at long-distance HDMI transmission, and specifically this device, the WolfPack 4K 60Hz HDMI receiver over HDBaseT.
Yeah. And our mission today isn't just to list specs. We really want to unpack how this technology fundamentally changes the game for getting high-quality audio and video where you need it. We'll dig into the tech behind it, why its features actually matter for, say, your home theater or maybe a commercial setup, and what it means for keeping that video quality perfect over distance.
Right.
By the end, you should have those real nuggets of knowledge to feel genuinely well-informed about this stuff.
Okay, sounds good. Let's unpack this. So the first hurdle, extending HDMI, the obvious thought is just get a longer HDMI cable.
Right, that's what most people think first.
But anyone who's tried knows that falls apart pretty quickly. Go beyond, 15, maybe 20 feet. And those traditional cables, they just start to struggle.
Oh, definitely. Signal degradation is a huge issue.
You have flickering, dropouts, maybe weird color shifts, loss of sharpness. It's just not reliable.
And let's not forget the cables themselves. They're thick, they're inflexible. Trying to run those through walls, it's a real pain.
Yeah, a total nightmare. So it's really not practical for bigger spaces or, serious installations.
Exactly. And that's precisely where HDBaseT comes in. It's really a technological game changer for this exact problem.
Okay, so how does it work? What makes it different?
Well, what's really remarkable is its core promise. Absolutely no compression, no signal loss, and virtually zero latency for your HDMI signal.
No compression. Yeah. That's big. Some of the solutions squish the video, right?
They do, yeah. And that can introduce visible artifacts, things you can actually see. HDBaseT avoids that. It takes the raw, uncompressed HDMI data and through some clever processing, packages it efficiently to send over standard network cables.
Network cables. Like Ethernet cables.
Exactly. Think of it less like zipping a huge file and more like giving your data its own dedicated high-speed express lane. Every pixel, every bit of audio arrives untouched.
Wow.
And the best part, it does this using familiar, pretty cost-effective Cat6 or CT7 cables, the kind you might already have in your walls for internet.
So you could potentially use existing wiring.
Potentially, yes. It really redefines what you can do with just a single network cable.
Okay, that sounds impressive. So for this specific WolfPack receiver, what kind of reach are we talking about? How far can it push that really high-quality 4K 60 video?
We're talking pretty significant distances here. This receiver is built to handle 4K 60 video from up to 220 feet or 70 meters. And importantly, with full 4.4.4 color compliance.
4.4.4, right? Explain that bit. Why is that important?
Good question. So 4.4.4 basically means you're getting the full color information for every single pixel. There's no reduction, no sampling down of the color detail.
Right.
This is really critical for things like super sharp text, in presentations, or really vibrant graphics, true-to-life images. You don't want any color smearing or loss.
Gotcha. And what about lower resolutions like 1080p?
If you're sending 1080p, it pushes even further. You can go up to 330 feet or 100 meters. That's a massive jump compared to what you can do with just HDMI.
That's a huge difference. So it's not just distance, it's maintaining that quality over distance.
Yeah.
But you mentioned this is specifically a receiver. What does that mean practically?
Right, that's a key detail. This WolfPack unit is an RX only, a receiver. So if you're thinking about the whole system, well, you need something to send the HDBaseT signal in the first place.
Oh, okay. So it doesn't work on its own.
Correct. You need an HDBaseT sending device. That could be a dedicated transmitter box at the source end, or maybe an output card in a bigger matrix switcher that has HDBaseT outputs.
I see.
This receiver is basically the final stop. It takes that HDBaseT signal coming down the network cable and converts it back into standard HDMI for your TV or projector.
Got it. So you pair this receiver with a compatible HDBaseT transmitter. And looking at the specs, it handles both 4K 30 and 4K 60, which is good.
Yep. covers the main bases.
And it comes with mounting clips, which is handy for installs.
Yeah.
A secure screw-on power adapter, which is a nice touch for reliability.
Little things matter.
Definitely. And it works with Cat6e and Cat-T7, but interestingly, the maker actually prefers standard CT6 for most uses.
Yeah, CT6 seems to hit the sweet spot for performance and practicality for the distances involved here. Okay, let's talk performance specs, because this receiver really delivers on quality. It's fully HDMI 2.0 and HDCP 2.2 compliant.
Which means
It works seamlessly with modern 4K sources and displays. No worries about copy protection issues or handshake problems with your gear.
good, that avoids headaches.
For audio, you get support for the top-tier uncompressed formats like 7.1 DTS Master HD and Dolby True HD.
Yeah.
Real cinema-quality sound.
Nice. And visually?
Visually, it supports 36-bit deep color and XOTV color. Depth color means smoother gradients, more realistic images because there are just more colors available. And XV color expands the color range even further, beyond standard RGB for more vibrant natural tones.
Okay, richer visuals.
Exactly, plus 3D support, of course. And it handles a whole range of resolutions, right up to true 4K 496 by 2160 at 30 Hz, and the common UHD 3840 by 2160 at 60 Hz, all backed by a solid 18 Gbps bandwidth capability.
You know, one thing that really jumps out, especially for long distance, is this claim of virtually zero latency. That sounds almost too good to be true. How low are we actually talking?
It is incredibly low, and it's a major advantage of HDBaseT. The numbers are pretty staggering. We're looking at less than 7 microseconds. It's 0.0000007 seconds over the full 220 feet for 4K.
7 microseconds. Wow.
And it gets even lower for shorter runs, like 3 microseconds over 100 feet.
Okay, put that in context. Can you even perceive that?
Not a chance. Human perception usually can't pick up latency below maybe 50 milliseconds. We're talking microseconds here. It's practically instantaneous.
So what's the real-world impact then?
Think about a big venue, a church, an auditorium, maybe live events. You absolutely need the image on screen to match the speaker's lips perfectly.
Oh, lip sync. Right.
Exactly. Or live sports. Any delay would be really jarring. This near zero latency ensures perfect audio-video synchronization every single time, no matter how far the display is from the source.
That really does make a professional grade.
Yes.
That's impressive. Okay, another feature mentioned is power over cable, POC. How does that work? What's the benefit?
POC is brilliant for simplifying installs. Basically, it lets you power both the transmitter and the receiver using just one power adapter at either end of the link.
Oh, so you don't need power outlets at both ends?
Potentially, no. As long as both the sending device and this receiver support POC, you just plug in one power supply, maybe at the source end with the transmitter, or at the display end with the receiver, and the power travels down the same CAT cable as the video signal.
That sounds incredibly convenient. Does it always work between different brands, though? Or are there catches?
Generally, if both devices are properly HDBaseT certified and state they support POC, it's quite reliable. The main benefit, really, is cutting down on the need for power outlets near every single display. It makes installs cleaner, faster, and sometimes cheaper, because you might not need an electrician to add outlets.
Yeah, I can see installers loving that. Okay, what about CEC, Consumer Electronic Control? What's that about?
CEC is all about user convenience, simplifying control. It lets your TV remote talk to other connected HDMI devices, up to 10 of them usually.
So like one remote to rule them all?
Kind of. For example, you could use your TV remote to turn on your TV, your Blu-ray player, and your AV receiver all at the same time with one button press. Or switch inputs on your receiver just by selecting the device on your TV menu.
Okay, that cuts down remote clutter.
Definitely. It makes the whole system feel more unified. But there's a catch.
Ah, there's always a catch.
Well, all the devices in the chain your source, the HDBase extender pair, your display, they all need to support CEC for it to actually work.
Right, compatibility is key. And I've heard CEC can be a bit inconsistent sometimes.
That's true. It's a great idea, but the implementation can vary. Manufacturers often use their own brand names for it, like LG's SimpleLink, Samsung's AnyNet, plus Toshiba's CE-Link. You get the idea?
Right.
And because interoperability isn't strictly mandated across all brands, sometimes devices don't play nicely together. Some manufacturers might even limit control mostly to their own products.
So while it can be fantastic, you really need to check compatibility within your specific setup. It might require some testing to see if it behaves exactly how you expect. Don't just assume it'll work flawlessly across different brands.
Okay, so CEC is handy, but needs checking. Now, let's circle back to that 4K 60 Hz 4.4.4 promise. We talked about how great that is, but you hinted there's some clever engineering involved because of HDBaseT's limits.
Yes, exactly. This is where a technology called color space conversion, or CSC, comes into the picture. It's a really smart way to handle a specific technical challenge.
What's a challenge?
The challenge is that the fundamental HD-based technology has an inherent data rate cap. It's limited to 10.2 gigabits per second.
Okay.
But the highest quality 4K signals, like 4K 60 Hz with that full 4.4.4 color, actually require more bandwidth, up to 18 gigabits per second.
Ah, so the pipe isn't quite big enough natively.
Precisely. So HDBaseT can't pass that full 18 Gbps signal natively without some help. That's where CSC steps in.
How does it help? What does it convert? CSC intelligently reduces the overall data rate just enough to fit within that 10.2 Gbps limit. It does this by converting the color space. Think of it as the range and precision of colors from the highest format, like 4.4.4 or maybe 4.2.2, to a slightly lower format during transmission.
Okay, so it reduces the color information slightly. Does that impact the picture?
Here's the really crucial part. CSC is designed so that the native resolution, the frame rate, and the color depth all remain constant. They're completely unchanged from the source to the display. Only the way the color information, the color gamut, is represented is temporarily adjusted for the journey down the cable.
I see. So it's not like reducing the resolution or making the motion jerky.
Not at all. Think of it like, imagine you have a very detailed, colorful image. CSC doesn't shrink the image or reduce the number of pixels or how fast it updates. It just finds a slightly more efficient way to describe the colors temporarily so they fit through the HDBaseT pipe. Then, at the receiver end, it perfectly reconstructs the original color information.
So visually, you shouldn't notice a difference.
For the vast majority of content and viewers, the conversion is visually lossless. You still get that crisp 4K image, smooth 60 Hz motion, and vibrant colors. It's a clever engineering solution to overcome that bandwidth limitation without a visible sacrifice to the core viewing experience.
That is pretty smart.
Yeah.
However, the source material we looked at did mention specific limitations, particularly with some HDR formats.
Yes, that's an important nuance to understand. Specifically, the documentation states that HD-based products using the CSC technology, like the ones from HDTV Supply, do not support HDR10 Plus or Dolby Vision.
Okay, why not those specific ones? Standard HDR10 works.
Standard HDR10 generally works fine. The issue with HDR10 Plus and Dolby Vision is that they use dynamic metadata. This means they send extra information about brightness and color scene by scene, or even frame by frame. These formats transmit repeated metadata packets throughout the signal. And current CSC technology isn't designed to handle that continuous stream of dynamic metadata correctly during the conversion process. It essentially disrupts the conversion.
So if you absolutely need HDR10 Plus or Dolby Vision, HDBaseT with CSC isn't the right fit.
Correct. For those specific cutting-edge dynamic HDR formats, you'd need to look at solutions that can handle the full 18 Gbps bandwidth natively, which usually means different transmission methods, often fiber optic based, or much shorter cable runs.
So what does this all mean for you, the listener? When is CSC okay, and when do you hit this limit?
It means for most high-quality 4K setups, watching movies, gaming, presentations, where vibrant color and sharp 4K 60 resolution are key HD-based case, with CSC is an excellent visually transparent way to go the distance. You likely won't see any difference.
Okay.
But if your specific application absolutely hinges on using content mastered in HDR10 Plus or Dolby Vision, and you need those dynamic HDR effects perfectly preserved, then you need to be aware of this specific limitation of current HDBaseT CSC implementations and plan accordingly. It's about matching the tech to your exact content needs.
All right. Beyond the specs and the clever tech like CSC, let's get practical. What about actually installing this, getting it running smoothly? The sources had some really solid do's and don'ts.
Absolutely. Good installation practices are crucial to get the performance you're paying for. Let's talk cables first.
Okay, what's the recommendation?
The recommendation is solid core CD6, 66A, or CT7. Interestingly, as we noted, CS6 is often preferred. It hits a good balance of performance, cost, and ease of installation for these distances.
Solid core, not stranded patch cables.
Definitely solid core for infrastructure wiring, and termination is critical. You absolutely must follow the TIA EIA 568B wiring standard when putting the RJ45 connectors on the ends.
568B, that's the color code standard, right?
Yes, it dictates the precise order of the little colored wires inside the connector. Getting this wrong is a common cause of problems. Slow speeds, connection drops, all sorts of frustrating issues. Use a good quality tester to verify your terminations.
Good tip. What about shielding?
Very important, especially in electrically noisy environments. The recommendation is to use shielded KD6 cable, often abbreviated STP or FTP, along with metal RJ45 connectors,
Why shielded?
to protect against EMI electromagnetic interference. Think of noise from power lines, fluorescent lights, motors, even microwaves. This EMI can cause video flashes, sparkles, or even complete signal dropouts on your HDBaseT link. The shielding acts like a barrier.
Okay, so shielded cable, metal connectors, terminated to 568B. What about things to avoid?
The sources were very clear on a couple of points. First, don't use EZ45 connectors.
This is the pass-through ones, right? Convenient, but
Convenient, yes, but they can potentially lead to less reliable connections for these high bandwidth long distance signals